The 1996 National Electrical Code, or NEC, mandated the bonding of a motor to the plumbing pipes in a residential setting. This requirement stems from the fundamental principles of electrical safety and the need to establish an effective ground fault current path. The primary purpose of bonding is to ensure that all metallic parts within a building's electrical system and its associated infrastructure, such as plumbing, are at the same electrical potential. This equipotential bonding minimizes the risk of electric shock should a fault occur. For example, if a live wire accidentally comes into contact with a metallic pipe. When a fault occurs in an ungrounded system, the voltage potential of the faulty equipment rises relative to ground. If a person touches the faulty equipment and a grounded object, such as a water pipe, they could become a path for the fault current, resulting in a potentially lethal electric shock. Bonding reduces this voltage difference, providing a low impedance path for fault current to return to the source. This low impedance path facilitates the rapid operation of overcurrent protective devices like circuit breakers or fuses, quickly disconnecting the power and mitigating the shock hazard. The NEC addresses bonding requirements in Article 250, specifically focusing on grounding and bonding. These requirements are designed to protect people, livestock, and equipment from electrical hazards. The code mandates that all metal parts that are likely to become energized be bonded together and connected to the grounding electrode system. This includes items such as metal water piping, gas piping, metal conduit, and enclosures for electrical equipment. Bonding methods typically involve the use of copper conductors, sized appropriately according to the applicable NEC tables, to connect these metallic parts to the grounding system. The size of the bonding conductor is determined by the size of the overcurrent protection device protecting the circuit. Specific NEC tables, such as Table 250.102 cone, dictate the minimum size of the bonding jumper based on the size of the ungrounded conductors or the equivalent area for parallel conductors. The bonding connection must be made in a secure and reliable manner, using approved connectors and methods. It is crucial that the connection points are clean and free from corrosion to ensure a low impedance path. Improper bonding can lead to increased impedance, which hinders the flow of fault current and increases the risk of electric shock. The grounding electrode system is a critical component of the overall grounding and bonding network. It provides a connection to the earth, helping to stabilize the voltage to ground and provide a path for fault current to dissipate. The grounding electrode system typically consists of one or more grounding electrodes, such as a metal underground water pipe, a ground ring, or ground rods. These electrodes are connected to the building's grounding system via the main grounding conductor. The connection to the metal water pipe must be made within 5 feet of where the water pipe enters the building. If the water pipe is interrupted by an insulated coupling or fitting, a bonding jumper must be installed to ensure continuity of the grounding path. Ground rods, typically made of copper or copper-clad steel, must be at least 8 feet long and driven into the ground to a depth of at least 8 feet. If rock bottom is encountered, the ground rod can be buried horizontally in a trench at least 30 inches deep. The NEC also addresses the bonding of specific equipment, such as motors, to the grounding system. Motors, especially those with metallic frames, are considered likely to become energized under fault conditions. Therefore, they must be bonded to the grounding system to minimize the risk of electric shock. The bonding of a motor typically involves connecting a bonding conductor from the motor frame to the equipment grounding conductor within the motor circuit. This equipment grounding conductor runs along with the circuit conductors and is connected to the grounding bus bar in the electrical panel. The size of the equipment grounding conductor is determined by the size of the overcurrent protection device protecting the motor circuit, as per Table 250.122 in the NEC. It is important to note that the equipment grounding conductor must be installed within the same raceway or cable as the circuit conductors to ensure a low impedance path. Running the equipment grounding conductor separately can increase the impedance and hinder the flow of fault current. In the specific case of a house built in 1996 with all copper plumbing and a motor having a lug for bonding, the 1996 NEC would have required the motor to be bonded to the plumbing pipes. The absence of a bonding wire in this situation would be considered an oversight, as it violates the code requirements for grounding and bonding. The bonding connection should be made using a copper conductor of the appropriate size connected securely to the motor frame and the plumbing pipes. The connection to the plumbing pipes should be made as close as practical to the point where the pipes enter the building. The failure to bond the motor to the plumbing pipes can create a significant safety hazard. If a fault occurs in the motor and the motor frame becomes energized, a person touching the motor frame and a grounded object, such as a water faucet, could receive a severe electric shock. The bonding connection provides a low impedance path for the fault current, allowing the overcurrent protection device to quickly trip and energize the circuit, mitigating the shock hazard. It is recommended to consult with a qualified electrician to assess the situation and install the missing bonding wire in accordance with the 1996 NEC requirements. The electrician can ensure that the bonding conductor is properly sized and installed, and that all connections are secure and reliable. Regular inspections of the electrical system, including the grounding and bonding connections, are essential to ensure continued safety and compliance with the NEC. Over time, connections can become loose or corroded, compromising the effectiveness of the grounding and bonding system. Addressing these issues promptly can prevent potential electrical hazards and ensure the safety of the occupants. In summary, the 1996 NEC required the bonding of a motor to the plumbing pipes in a residential setting. The absence of a bonding wire would be considered an oversight and a violation of the code. Bonding is essential for electrical safety, as it provides a low impedance path for fault current, minimizing the risk of electric shock. It is recommended to consult with a qualified electrician to ensure that the bonding system is properly installed and maintained.